In these next two examples, we want to describe the long-run behavior of each function using limit notation and give the equations of any horizontal asymptotes. All right. So in the last example, we saw that long-run behavior just describes the behavior as x approaches infinity or x approaches minus infinity. So what we want to do is we want to look at the limit as x approaches infinity, and we want to look at the limit as x approaches minus infinity. All right, now this function just says y. So I'm going to name this function. I'm going to say that y equals f of x, all right, because I like the function notation when we're talking about limits. So I'm going to say the limit as x approaches infinity of f of x is what? So what's happening as x gets larger and larger and larger and larger in the positive direction, right? Because we're talking about positive infinity. So you can see as I go along this curve, x gets bigger and bigger and bigger. It looks like it's approaching an asymptote. It's approaching 5. So I'm going to say that this is 5, right? We're assuming that all the important features are shown. So this is looking like as x approaches, or as x gets larger and larger, it looks like the value of the function is approaching 5. All right. So we can describe the long-run behavior as x goes to positive infinity that way. Now we also want to look at the long-run behavior in the other direction, in the negative direction. So what's happening now, right, as I approach negative infinity, as x gets more and more and more negative, right? So they're larger negative values, right? They're really smaller values, but the magnitude is larger. So they're more and more negative. What's happening? It looks like the y value is just getting bigger and bigger and bigger and bigger and bigger too, right? So we can say that as x approaches negative infinity, the value of the function is approaching infinity, right? It's growing more and more and more, getting bigger and bigger and bigger in the positive direction. All right. All right. So we defined an asymptote to be in terms of long run behavior. And so if the limit as x approaches either positive or negative infinity, if it approaches some constant value, that's an asymptote. So you can see that as x approaches positive infinity, we have an asymptote at y equals 5. So that is the horizontal asymptote y equals 5. All right. So let's go ahead and look at the next example as well. All right, so we want to do the same thing. We want to look at the long-run behavior of the function and find the equations of any asymptotes. All right, so we're going to look at the limit as x approaches infinity and the limit as x approaches minus infinity. Now again, I didn't name this function. It's just y, and y is a function of x. So I'm going to name it. I like my functions to have a name for this purpose. So I'm going to say y is equal to g of x, since I called that other one f of x. All right. So the limit as x approaches infinity, I just want to look at what's happening as x grows larger and larger and larger. So that we're going in this direction. It looks like as x gets larger and larger and larger, we're going, the y value is getting more and more and more negative, right? So it looks like it's approaching negative infinity. All right, so I would say that's how I would describe the end behavior. As x approaches infinity, g of x approaches minus infinity. All right, so let's look at the case where we're approaching negative infinity. So the value of x is getting more and more and more and more negative. All right, so we're going in this direction, and you can see again we're getting the same issue. The y value is just getting more and more and more negative, so it looks like it's approaching negative infinity when x approaches negative infinity. All right, so I've described now the end behavior of the functions. That's how we describe the end behavior using limit notation. And remember that if there are any asymptotes, then the limit approaches some constant value. Now, negative infinity is not a constant value. That is a different, that's not a number, right? It's just a, it just gets bigger and bigger and bigger. It's not a constant. So there are no asymptotes. Asymptotes for this function. So, all right, we're done. I'll meet you in the next video.